Hi, and welcome to Data Scotland's Scottish Summer. I'm John McCormack, and today I'm going to be talking about 7 ways for data teams to save money in Azure. So, just making sure we're not spending more than we need to. I've been working with data and databases since about 2012. I'm a principal DBA, and I'm focused mostly on SQL Server, but also work with SQL Database, AWS, and Azure. So the point of today's talk is to make sure that you're optimized, that your costs are optimized, you're not spending more than you need to, and there's going to be seven hints to give you a start on the journey of cost optimization. So it's by no means exhaustive, and if you have made a start, there might be one or two things that you've not done, and there are a few other suggestions at the end that I'm not going to go into a lot of detail about. Now, on my own site, johnmccormack.it, there's a blog post for each of these 7 ideas that goes into it in a lot more depth. So we're going to try and cover this in about 15 minutes today. So there's not going to be a whole load of depth covered, but hopefully we'll be able to give you some good ideas to get started. So we're going to look at reviewing your backup retention policy, making sure that everything is right sized in terms of your resources in Azure, talk about tuning queries, um, talk about how we can turn some instances off out of hours to save some money. Look at the Azure SQL DB serverless option. Um, Also, a little bit of a investigation into reserved instances and how they can save money. And finally, how we can keep an eye on unused instances and make sure that we delete them if they're no longer needed. So the first thing here is review your backup retention policy. Now, this is more specific to people who are running SQL Server on the VMs, which is known as infrastructure as a service. And also if you're running SQL Server on premises, on your own servers, but you might be using the backup to URL option. So your backups are going to blob storage. So if you keep all the backups, especially for like transactional databases where you might be taking transaction log backups, then over time, the size of the amount of backups that you're retaining can be pretty large. And it's more likely than not that you're not going to need to, say, restore to a point in time beyond a few weeks. So whilst you might want to keep all your transaction log backups for a couple of weeks, beyond that, you want to have a process for just automatically purging them out of your storage account so that you're not just storing data that will never be used. Same with your full backups. You might need to keep backups going back 7 or even 10 years, which is absolutely fine. But you might not need every day's backup for those 7 or 10 years. So there's ways that we can go about making sure that we just keep what we need and we're optimizing the amount of storage that is used and paying the optimal price. So one thing that Azure offers in blob storage is lifecycle management. And in the lifecycle management, it allows you to set some rules to automatically delete files. So you set the rules. If you don't need the files beyond 2 weeks or 6 months or a year, whatever the rule is, whether it's specific folders or file extensions, you can do that in the lifecycle management. If you are running SQL Server on VMs, then one thing that's not just related to saving money, but might actually make your life a bit easier as well, is to look at the IaaS agent extension, which is supported for SQL Server on VMs. One of the options it offers is automatic backups, and you can set your backup rules in there as well so that you're not retaining more than you need to. That kind of bridges the gap between a fully managed service like SQL DB and running it yourself, like on the SQL VMs. So it's a really good thing that's worth checking out, not just for cost optimization. There's also an Azure backup product where you can set your automatic backup rules. And the final way is to roll your own solution. Now, I've done this via PowerShell and Azure automation accounts, and it just lets you have a more fine-grained detail about what you want to retain and what you want to delete. That isn't always available with the lifecycle management. But I would urge you to look at lifecycle management first because that's probably the best way to get started. Okay, so let's make sure that all the resources you've got in Azure are sized at the right level, or certainly not far too big anyway. The cloud is scalable and it's elastic, which means that you don't need to buy for the future like you did in the past when maybe you were scoping out a server that was going to be your main SQL server for the next 5 years, and you anticipated what the growth would be of the business and how large the databases would be, how much traffic you're expecting to see, how many transactions. That's not really the case with the cloud. You can basically scale up as you go. So if the business grows, or the database grows, and you need more storage, or you need faster storage, or more CPUs, then they can all be scaled at the time that's right. So you don't need to buy in advance, just pay the right amount at the right time. So buying those old servers that way was called a capital expenditure. And the kind of new way of thinking is to put your cloud costs as what's known as operational expenditure. So there's no big upfront costs. You just pay what you need on an ongoing basis rather than a large capital expense. You should monitor your usage. So for all the resources you've got Azure Monitor, which is going to let you know whether you're using a lot of, whether it's DTUs or vCores or CPUs. You can set alerts so that you're notified when certain thresholds are breached in case you do need to scale up. You can also do that on the vice versa if you are underutilized. Usually it'll be safe to scale down. I'm talking about SQL database here. You can normally scale down because it's easy enough to scale back up if the time comes, but you must bear in mind that not all features are available at all tiers. So if you're using something like scale out replicas or column store indexes on some kind of premium or business critical tier, then sometimes moving that down to a more sort of standard or general purpose tier, you're not going to get everything that you need. So make sure that it's not just that you've got more overhead and you think you can slide down. Just make sure that your features are covered. And if they are, it's probably a good, safe idea to scale down. And if you're not getting the performance you expect, it's easy to just move back up again. Scale up when the time comes and not before. I kind of covered that at the start of this slide. So there's no need to be oversized for how you're expecting your future needs to be. And a final one here is if you are running SQL Server on VMs using the IaaS solution, all of those VMs, we're talking about Windows ones here, come with a D drive, a locally attached storage. And that gives you the best performance for TempDB and also means that you're not using space that you could have your other user database files on other storage. So make sure that you're utilizing that. It comes within the cost of the instance anyway, and it's actually going to give you the best performance. So it's a bit of a no-brainer. Okay, so the next thing is tune your queries. So that might sound kind of obvious, and in the SQL Server world, certainly on premises, tuning your queries can give you better performance, give you a little bit more headroom on the servers. But once the server's been bought, there's not really an immediate financial benefit. It's different in the cloud. In the cloud, if you're on a fairly high instance class, and you can tune some queries that mean that you can scale down to a lower instance class, then you're going to save money straight away. Okay, so there's real pounds and dollars to be saved by making sure that your queries are efficient as possible. So how are you going to find your sort of top consuming queries? Well, the Azure portal itself has this intelligent performance section where you can see an overview, you can see your high performing queries. It also has an automatic tuning section as well. There's the query store that you can access from within Management Studio. And if you use the query store, you'll be able to see sort of quite useful intuitive graphs that show which queries are using the most resources. And sometimes you might have queries that are performing well on some plans and not well on others. And using the query store effectively will help you optimize that. And the last thing is there's open source scripts as well out there in the community to help you read some of the DMV data and make sure it's easy to digest and understand exactly what your problem queries are. Okay, so moving on, let's make sure that we turn the non-production instances off out of hours if they're not required. So if you've got a machine spun up for a developer that's working 9 to 5, Monday to Friday, you don't want to be paying for that overnight when the developer's sleeping. You don't want to be paying for it over the weekend when nobody is working as well. So you can do this with some resources in Azure and not with others. So you can do it with your SQL VMs, you can do it with your your Synapse SQL pools. You only pay for the compute that you use. So you'll still pay for the storage even when the compute is shut down, but you won't have to pay for any of the compute costs, which is a massive saving if you think about sort of Monday to Friday hours. Now, what's very important here is that you have to make sure that the status is deallocated for your VMs if that's what you're going to do. So simply hitting shut down from the VM isn't going to actually deallocate that resource in Azure, and you're still going to get billed for it. But if you use the Azure portal, if you use CLI or PowerShell, then those methods are all going to make sure that it's properly deallocated and you stop getting charged for it. So there's really huge benefits to be made there. You probably want to do some automation with this as well. Now, when you spin up a new instance, it can actually be done at the time. And another way to do that is just using automation runbooks. So with a PowerShell script and adding some tags to your various VMs, you can automatically make sure that things are shut down at the times that are expected and brought back up again in time for the next business day. Consider moving to SQL DB serverless where it's the right fit. So it's not always the right fit, but sometimes it is. So the way that SQL DB serverless works is it's a bit of a misnomer because obviously, like most serverless solutions, there are servers behind the scenes, but you're effectively just not using it for a period of time, and that means that you don't have to pay the compute costs. If you have no queries hitting a database for any time between 1 hour and 7 days, and you can set that period yourself, then the database will auto pause, and that means that you're only going to pay for the attached storage, which is a great thing for, say, developers that are using SQL DB, because you can't normally pause a standard SQL DB, and just when they come in the morning and start running queries, it will fire up again and you'll start getting billed again. You can also use it for auto scaling, so you can set anywhere between a half to 40 vCores, and that's really good for workloads that are full of peaks and troughs. It's not great for steady workloads. You'll probably be cheaper to just kind of right size the instance if you've got a steady workload, steady utilization. But if you do have a lot of ups and downs and a lot of quiet periods and times where there's no activity at all, then SQL DB serverless is a great option. Just remember that your application should have some retry logic in it. The error it throws out if the machine has been stopped and it's the first connection is 40613. So just make sure you're including that in your application to make sure that you're not throwing errors. Okay, so reserved instances is the next thing on our list. You can save up to 72% on VMs and 33% on SQL database. So you would commit to having an instance type for 1 or 3 years. If you look at what's available within reservations, you can see all the classic things for a data team. So Data Factory, SQL Database, Synapse Analytics, VMs, Databricks, even things like Cosmos DB and MariaDB, Azure Database. There's loads and loads of things that you can save money on. I've just tried to highlight some of the main ones there. But whatever you're doing, there's a good chance there'll be some option to buy some reserve capacity, and that will make your bill overall cheaper. So you can save like 33% on the SQL database, 65% on Cosmos and Synapse, and 55% on Azure Cache for Redis. So that's definitely worth a look on the Azure website. And the last of the sort of 7 main tips is to make sure you're deleting unused instances. That might sound pretty obvious, but it's amazing when you look at a company's SQL estate or Azure estate, just how many things are running that aren't really needed anymore and have perhaps been forgotten about. The more open your permissions are for allowing people to create things, say in non-production, then the more of this you're going to get. So the best way to go about this is make sure that all your resources are tagged. Have an owner tag and a project tag, and that way you can hopefully know who is responsible for it and what it's for. And then you can challenge them if you think it's over-spec'd. See if we can bring it down a tier or two. See if it needs to be online all the time. And sometimes they do, and that's fine, as long as you're asking the questions and making sure that you're on top of things. Try not to allow untagged resources, and you'll keep this well under control. Okay, so we're almost out of time, so just a quick list of some other ideas that I'm not going to cover in detail. You've got elastic pools. Elastic pools are a way for you to run multiple SQL databases against the one set of resources. This is really useful if you've got databases that are busy at different time zones. You can share the resources. There's the Azure hybrid benefit, and that allows you to save a lot of money on license costs if you meet certain conditions. So if you use that along with something like reserved instances, your savings can be really, really large. You can get a cloud solution provider, which is a third-party company that's actually reselling you Azure services. And quite often, without doing anything else, they'll just be able to take a few percent off your bill. It's always worth a look. Finally, on the database side, just make sure that you're not hanging on to old data that you don't need. So if it's not required, let's get it deleted, because the smaller the databases, and also if it doesn't have lots of unnecessary indexes on it, then your performance is going to be a bit faster. You're not going to need such a high tier of database, hopefully. All of these things can build on each other. So it's not just a case of doing one and doing the other. With all the 7 ideas that I mentioned and these other 5 quick ones, you'll probably find a combination that makes sure that you're optimizing your costs as well as possible. So I'm going to finish up there. Just want to say thanks very much. Some contact details if you want to get in touch about the talk or anything else. So you can tweet me at @actualjohn. My website, as I said, which has got the 7 blog posts on it, is johnmccormack.it. I'm on LinkedIn at John McCormack DBA. This is the website here. If you just click on this link in the second top right, Save Money in Azure, that's going to bring you up this page, which links to all the other detail. If you've got any comments or questions, then please get in touch with me. I'll be delighted to hear from you. And thanks very much for listening.